Chemical names and formulas. This is fun stuff, chapter 9. Now, we've already done a lot of naming ions, so hopefully a lot of it's review. We did put ions together, and I had you guys do the names, so we didn't have to do all this at once. So let's get right into it. Now remember, ionic compounds consist of a positive metal cation and negative anion. So a positive metal and a negative nonmetal. We put it together, and again, they have to be in the right ratios. And we had you put the IDE at the end. All right, so it's really nothing's changed since then, except when we get to transition. Now it's a cool, hip, chill, fun way of naming ionic compounds from the formula. So we're going to be given a formula and we're going to name it. Rules. And we're going to name the cation. So remember, the cation just is it's the same name as the original element. So sodium is sodium, magnesium, magnesium, lithium, lithium, etc. Now, number 2, the cation, if the cation is transition metal, we're going to put a Roman numeral to indicate the charge of the cation. This is a little different. So before we weren't even dealing with the transition. Now we are. And we're going to get to that in a little bit, so let's hold on for that. So we're going to first just do naming the representative cations with the anions. And then a little later, we'll do the transition. So then the anion is just the anion. So remember, we add an IDE to it. I'd say that is correct. Name the anion. So let's just do a little bit of practice. So again, it should just be review. Calcium. Now these are all representative. They all represent. These cations are representative, so it's just easy squeezy, or whatever you teens say these days. So this is going to be calcium chloride, have the IDE. This is magnesium fluoride, aluminium sulfide or aluminum sulfide, and sodium chloride. Okay, we've done it. Easy. Just review. Yeah, there's a periodic table. Now let's look at naming the transition metal ions. This is a little more challenging. It's actually easier to name go from the name to the formula with the transition element than with representative. It's pretty easy, so we'll get to that. Now notice we have symbol up here to the left, stock name. The stock name is basically what we're going to be calling it now. The classical is the old name. This is taken directly from page 255. You do not have to memorize all these. It's just very good to know that they exist, and if you see something, when we've seen chemicals in our lab, and you'll see them in future labs, or you've seen them somewhere else, that might say cuprous, like cuprous chloride. You think, what is cuprous, or what is cupric, or what is ferrous, or mercurous? It's the same thing as this. Okay, so it's important to know that they exist. They're not two different elements. So if we're talking about stannous, that's actually tin. Remember, stannous, that the symbol for tin is Sn. That's stannous. Or plumbous, the symbol for lead is Pb. That's the old way, but they still name chemicals, and you'll still get them that way. But we're going to be really having to learn this. The new way is much easier, makes much more sense than the old way. The reason why transitions are so special is because they have different ionizations. They can create different ions. So it's important that we know that. And so, for example, we have copper up here. Copper has a plus and a 2 plus, for example. So a plus would be, in the new way, copper 1. That means it has one ion, one charge. So transitions will always be positive. They'll be positive metals, cations. Copper 2 plus, the 2 corresponds to the 2 here. And the 2 plus for the iron is 2 here. The 3 is means it's ion 3. Lead 2 means it has an ion charge of 2 plus. Lead 4 means it has an ion charge of 4 plus. Tin 2 plus means it's tin 2. Tin 4 plus means it's tin 4. Chromium 3 plus means it's chromium 3. Now, when you're naming these, it's a very common thing to say there's 3 chromiums if there's a chromium 3. No. It's not 3 chromiums. That means that chromium has a charge of plus 3. It's a common mistake people make. When we're naming these, they'll say, well, chromium 3 is Cr3. No, it's 3 plus. That's the charge of the ion. Now, isn't this so much easier than trying to remember cuprous? Is that the 1, or is it cupric is 2 plus? Plumbus or plumbic, and manganous or manganite. Let's see, what is that? It's just a much easier, much more elegant way of naming things. Just using a Roman numeral to represent the charge. That's what we'll do. And again, remember it's a charge. It doesn't mean there's 1 mercury or 2 mercury. It doesn't mean it's 4 leads. It's the charge of the ion. So let's practice this. This actually can be quite fun. You can try it at your EC parties. So cobalt chloride. So cobalt, we know, is a transition metal, atomic number 27. So when we have a transition metal, what we have to do is look at the anion, look at the negative, and see what the charge is. Once we know what the charge of the anion, we can know what the charge of the cobalt is, and then we can name it. So the charge of chlorine is -1. And look, there's no subscripts, so that means it's a 1-to-1 ratio. So the charge of cobalt must be plus 1. So this is going to be, it's just a 1 plus for that transition. It's going to be cobalt 1 chloride. So when naming these, chloride, I misspelled, I made it chloride. Alright, so when naming these, you have to look at the anion first to see what that charge is, and then to see what the charge of the transition metal will be. Look at this, a different one. Chlorine, again, same one, but it's 2. So that has a total charge, if there's 2 of them, it has a total charge of -2. And there's only 1 of these, so it has to make it a +2 to balance it out. Because there's 2 negatives here, this has to be +2. So this is going to be cobalt, and there's a +2 here, 2 chloride. People will get in trouble because they'll think it's a negative number or they'll just mix things up. You have to realize that this -2 causes this to be a +2, and if it's a +2, it's a cobalt 2 chloride. Let's look at silver sulfide. But what is it? Silver 1, silver 2, silver 3? Well, sulfide has a charge of 2-. Silver, thus, it's a 1-to-1 ratio, so that means this silver must have a charge of 2 plus. So it's going to be silver. And my pen is weird, acting weird. 2, because it's 2 plus. Sulfide. I don't know why my pen keeps acting that way. And a lot of people will mix up. They'll see there's only one silver here, so they'll say it's silver 1 sulfide. But you have to again look at that charge. It's a 2 plus, so it's a silver 2 sulfide. You don't look at the subscript. Now this confuses a lot of people, such as when we get to naming covalent bonds, because that's when we use prefixes. But with the transition, we look at the ions, the charge to name it. All right, now this is 2. Now the sulfide here, sulfur, is 2 minus. It's always going to be 2 minus. That doesn't change. It's the transitions that change. Now we notice that there's 2 silvers. So that means it has to be a minus and a minus. You have to balance it out. So that's going to be, if it's a charge of 1, it's a charge of 1 minus, it's silver 1 sulfide. So let's try some more. Again, you should probably just try this on your own and see if you get the right answer. So nitrogen, look at the anion first. Nitrogen is 3 minus. Lead, plumbus. What is lead must be? Well, it's a 1-to-1 ratio. There's 1 lead for every 1 nitrogen. So that has to be 3 plus. So it's going to be lead. 1, 2, 3. Nitrate. Or no, I'm sorry, not nitrate. We will get to that. Nitride. Okay, the 3 plus shows that it's a 3 here. Let's look at this next one. And of course, you can just pause. I'm just going to go through it, but I would pause it, try it, and see if you come up with the same answer. So this is, again, 3 minus. That doesn't change. So there's 3 of these. Well, if there's 3 of these, what's the charge to balance out this 3 minus? Well, it has to be a plus. And so this is going to be a lead. It's plus 1. So it's a 1. Nitride. And I think the ink is running out of my pen. I'll have to get a new pen. Lead 1 nitride. Now the next one. Now also you can see, you can even, again, just switch it. There's 1 here and there's 3 here. So give this the 1 charge and give this the 3 minus charge. You can try it that way as well, but I mean, I just think it's just as easy just to eyeball it as well. All right, so nitrate, 3 minus, excuse me, and there's 2 of them. So there has to be, and there are 3 of these, as we're given. And this is a total charge of -6, so this has to be a total charge of +6. And we can see that this has a charge of +2, so that's going to be lead 2 nitride. And also what you can do is just switch these and say, well, this is going to be the negative, this is going to be the positive, so this is going to have, this one will be Pb +2, or Pb2.